Hey, what's up, boys and girls? Brad the Guitologist here. In this video, we're going to check out this 1974 Marshall Super Bass Mark II. We're going to get into the schematic. We're going to compare the Mark II Super Bass to some of the other Marshalls from the time period. This one, I think he said that it's not passing any signal. So we're going to figure out why it's not passing signal, and then we'll just kind of go from there and see what all needs to be done. So if that sounds like something you'd be interested in, stick around. Okay, so here is the rear of the amplifier. This was a Mark II Super Bass, which means that this would have come stock with 6550 tubes on the output, and it has been converted to EL34s. Looks like somebody has put quad of JJs in here. You can also see that it's been serviced at some point. All of the capacitors are new, so that's that much less that we have to do. So, or at least I presume we won't have to do anything with those because they do look rather new, and they are CE distribution capacitors. He did say that this thing had been serviced somewhat recently, but that it, like I said, it's just not passing signal now. Here you can see where it tells you to replace with 6550s only. So this would have been a North American variant of the Super Bass for the time. And again, this is from 1974. You can see there. And it's signed Poly up there on the top.
So I had heard at some point that Dave Mustaine of Megadeth and early Metallica fame had a Marshall amp from the 70s that he affectionately named Poly because it was also signed by Poly. If you guys have any information about that or who Poly is, please let me know.
As far as preamp tubes, I'm not sure what these are. What does that say? That's this Cryotone. Not really sure who made these, but they look Chinese to me. If I had to guess, they're Chinese preamp tubes, but I don't know for sure. This one does say it's a 12AX7, but it looks totally different. See the mica wafer up on the top there? There's two of the mica wafers, and the plates are really small and kind of compact on that one.
Okay, so I Googled these tubes to figure out what these were, and these are actually Wathen Cryotone tubes, and oh my goodness, $117 and $108 they want for these tubes. Apparently, according to this little article in Sweetwater, that this is Swart Amps talking about these tubes. We're always looking for something that does the job well, and just when you think you have a handle on something, it's nice to know there can still be surprises. Enter cryogenics or freezing the beast. I had personally messed around with cryogenic tubes with my high-end audio tube amps and found some. Well, there's your first clue that this is snake oil right there. High-end audio. Just about everything around hi-fi is high-end hi-fi is going to be snake oil. But with guitar amps, neither Michael nor I had experimented with them in guitar amps. We had heard a few good rumors as of late. However, when the guys at Wathen Audiophile, there you go, Audiophile, asked us to give their Cryotone a listen, we jumped at the chance. Really, I don't know, man. $117 for a single preamp tube. You have got to be joking me. So let's go to Guitar Center. So they do have actually two different styles of tube here, both of which are represented in this amplifier. This one's in the phase inverter, so I mean, just about any old tube will work in a phase inverter. I don't know why they would spend $117 on a phase inverter tube. I mean, oh, dude, it's I mean, shit. There's over $300 in just preamp tubes in this amp. I don't understand. Okay, so this is the one with the two mica wafers on top, the one that we were just looking at. The Cryotone 12AX7 WCB is an incredibly sweet-sounding tube. It has slightly more pronounced upper mids than the WCM, which can be good for blues and especially jazz. This tube is very responsive, fast to the touch with a fast note bloom, which makes it a bouncy, I mean, all these buzzwords, note bloom and bouncy feel, and tube seems to have a pretty high headroom, which for some might be a plus, but for others not. However, when the tube does saturate, the gain structure of is incredibly pleasant, does not overpower the fundamental tone of the tube. All right, so that's that one. What's this other one all about here? Are they going to say this one's more for rock? Probably. Rock and metal. Incredibly smooth rather than fuzzy, crunchy, or just plain harsh. Okay, well, hopefully. More pronounced mid-range, around 1K than the WCB, which is a helpful frequency range when wanting to cut through the mix. Okay, I mean, you know, again, this is snake oil, guys. Please don't fall for this kind of marketing crap. I mean, that's probably just a Chinese-made tube, repackaged. Just they might have gone through the trouble of hand selecting these, but then again, they might not have. Who knows? You know, I don't begrudge anybody having an angle in life or having a grift or a you know, way to feed their families. You know, making money is part of it, and sometimes, I mean, that's okay. There's nothing wrong with that. But this is a ripoff, if you ask me. I mean, these are just they're rebadged tubes. I mean, there's only like 4 or 5 factories in the entire world that make tubes, and it might be even down to like 3 now. That make tubes. I mean, the JJ factory and the Softtech and Ruby, the one where they make Ruby in China. I don't know if it's even still going. I think they shut it down. Didn't they shut that Chinese factory down? I don't even know. I'm not even 100% sure. But I do know this: $100 for a brand new preamp tube, a newly made one, is nuts. When you can go out and find an RCA or something, an old 7025 or 12AX7 RCA for that, or even an old GE or something, you know, made in the heyday of tube manufacture. This right here is just absolutely insane to me. I mean, save your money and put it into other areas of your amp. That's all I got to say about that.
If we look at these other tubes, you can see this one has a much longer plate than this one, and then this one has a short plate as well, but it has the 2 wafers on top. So all 3 of these are different, but apparently they're all 3 12X7s. So that's kind of odd that you would find that amount of variation in just 3. Oh wow, look at that! Look at that tube socket right there. Is actually pulling up. Well, that's no good. I'm gonna have to flatten this out right here. If not change it altogether, I might have to flatten that out and put a little washer on that to hold that down a little better. We don't have the main selector. Why is there no main selector? Did they not put a main selector on the Mark II? I'm not sure about that. I guess not. Okay. This has the newer version of the selector for the output as well. It doesn't have the one with pins that you have to actually remove the pins and move them around. This one has the actual switch, so that's actually good. That's better than, I don't like the pin version because those can get lost. This has been already changed to a 3-prong. This is a master volume, so I was told. He wants to keep the master volume. He said if I had some other mod suggestions that he would be all ears to different mod suggestions. So we might look into that and be thinking about that. Looks like somebody had a fan over here at some point, or maybe they just cut that out for airflow. I don't know. There's no fan in it, but at least not right now. Now, there's a spot where one could go. So yeah, I mean, this is a player grade amp, but it's it should be a good one if we get it serviced and up and going. So let's see what's wrong with it first of all. We'll go ahead and take the chassis out. Oh, and one more thing, we do have some numbers and stuff scratched back here, along with a former owner, a John Blakely, and 282507446. I'm not sure what that number is, but driver's license number, maybe? Something like that. Let me know now down in the comments if you have an idea what that is. Alright, here's the bottom of the amp. This thing has definitely had a life. It's been moved around a lot and sat on top of a lot of different amplifiers because we've actually worn down these little bubbles in the middle of the feet. 3 of the 4 are pretty much all the way worn out. It probably wouldn't be a terrible idea to just replace all 4 of these feet, but we're not, we haven't been given a mandate to do that. We're missing a couple of the chassis screws. I'll see what I might be able to drum up. Maybe I can get something, but I don't know if I have anything that's going to be appropriate or not. I'll have to look. But let's take out the 2 that are present and slide this chassis out of here. Oh wow, the captive nut is gone off that side. Looks like the captive nuts are gone off of the whole chassis. Oh wow. This thing's got a replaced power transformer. Got a loose screw there. I'm going to go ahead and hit that with a screwdriver. Okay, it actually looks like there's 2 transformers that have been replaced. It looks like this choke has been replaced also. That looks pretty brand spanking new to me. Or newer for sure. Hard to see the numbers off of it, but I'm pretty certain that's new. Then we've got the power transformer here. Made in the USA is a big giveaway right there, and 4/10 of 2012. That's what it looks like. So I wonder what kind of problem this thing had that warranted the replacement of both the power transformer and the choke. I mean, wow, that's something. You don't see a lot on these. Alright, here we are inside the amp, and we can see that yeah, somebody took some pains to pretty thoroughly service this thing at some point. Changed both the electrolytics on the inputs for the bypass capacitors. Here's another one that's been changed. These are Cornell Dubiliers, these 2 here. And then this one is it's probably over-spec'd at like 100 volts, but that'll still be fine. Got a couple of replaced resistors right here and here and here. We have more electrolytic caps down here that have been replaced, and it looks like the diodes have all been replaced as well. I don't think these are the ones that would have come in here. Somebody's gone through a lot of pains here to service everything, but you can see all this stuff that's coming up out of here. That's for the rather complex master volume back here. If we're not passing signal, this is probably one of the places I'd look, because this is all, there's so much going on here. It just looks to me as if this might be a good spot to start looking for some issues. Okay, right here. You see this? You're gonna have a hard time seeing this, but watch this lead right here when I pull on it. Okay, watch this one when I pull on it right here. When I pull on this one, it doesn't move. You know, it doesn't really go anywhere. This one, however, see how that's moving up and down? I can feel it actually moving up and down inside that hole. It's like there's a blob of solder on the other end of that line, but it's not attached to anything. At least that's the way it feels. So I might go ahead, before we even fire this thing up, I was going to say I might just go ahead and pull the board and inspect that, because I mean, that's not right. I'm going to have to lay eyes on that anyway, regardless. And I already can see that it's most likely a problem. Is this going to be a situation where we're able to fix it before we even have to fire it up? Probably. That's what it looks like to me. Let's go ahead and raise this board. Good God, who screwed that down? Man, it's like they're tightening the door on Fort Knox. Oh, it's dusty. Okay, let's see what's going on here. Hopefully I can lift this without too much trouble. Oh yeah, that trace is completely pulled away. Sure is. Well, that would be why it's not passing signal. I can see it right now. Yeah, this is definitely a problem. I don't know if it's the problem, but it's a problem for sure. This would not have passed signal, I don't think, like this. Or if it did, it would have been really jacked up signal, because look. See that moving right there? You see how it's not attached to this trace over here on this side? You see how that trace just ends right there before it gets to that lead? It's because that lead's been twisted and the trace has been broken. Whoop, wrong one. The lead's been twisted and the trace has been broken away. So I think I just need to desolder that, pull it up out of that hole, and just put it over here, probably on this component. Just tie it to this. That's probably the best way to go about it, because with that trace broken like that, I'm going to have to run a wire to complete that trace anyway, and it doesn't make any sense if I can just tie it to that leg right there of that capacitor. Yeah, these traces on these boards are garbage. They really are. They're very thin and very fragile. Okay. Yeah, there's a little bit of trace that just kind of came off as I came off of my soldering iron. Okay, she's on there now. Alright, well, I'm not going to tie the board back down yet. I'm going to put it back down on the standoffs and fire it up and see what it does. See if it passes signal. And if it does, I think this one can probably just go on, because I don't see a whole lot that I would really do to it, unless he wants just some kind of exotic mod or something like that. I mean, I could go ahead and do that, but he's already got a master volume on the thing. So that's been done. Yeah, I don't know. I mean, it's already also been modified to the lead unit specs, to the super lead specs here. You can see this 0.68. That wouldn't have been in the base units originally, but it is in this one. So it's already got that going for it. So, and everything else is good to go. I mean, we got 5 watt 1K resistors on the screens. All the electrolytics have been changed. Everything that I probably would have done has already been done. All the diodes have been changed out by somebody. All right, well, I mean, I think this is probably going to just fire right up. This is going to be a pretty easy fix and shouldn't cost really much more than the bench fee if he wants to stop right here. So that is if this is going to fix it. Let's make sure it fixes it. Okay, we got a dummy load hooked up. Gonna fire up the signal generator and put a signal to the input. We'll start with channel 1, test that channel first. The other thing too, the polarity switch has been already removed because it's got a 3-prong cord on it, so it doesn't need that. So yeah, like I said, I mean, this thing has had extensive repair. It's just that one little lead came loose. And it's kind of easy to see why it came loose, because these shielded cables are kind of rigid, and if it's being kind of moved around, well, it would have been pushed on, because it would have risen up slightly above the level of where this would have sat on the bottom of the cabinet. So it was constantly pushing on that wire. So I would say eventually, just after being moved a bunch of times, that lead broke that trace because it was being pushed downward. Let's bring her up on the Variac a little bit. We'll just bring it up slowly here, and we'll monitor our progress. Turn on the signal generator, set everything pretty much straight up and down, and we'll see where we get to here. And nothing looking unusual. I'm up to 48 volts already. Nothing looking unusual at all. Usually if there's a dead short or any kind of issue on my Variac, I can turn it up just a handful of volts, and I get the Variac will actually start physically shaking because there's because it doesn't like the current being forced through it like that. It might not be good for the Variac long term, but it is one way that I can tell if something has a dead short, like on the primary or something. So we don't have anything like that. So So we've got her up to 80 volts here. Okay, well, we got nothing so far. Why we got nothing? There's 100 volts on the input. Do we have glow on the tubes? We do. We do have tube glow. Even the tube socket that's loose, we got glow on that tube also. Okay, well, yeah, we're passing nothing. Maybe bring it on up just a little bit more. All right, we're up to about 120 volts, and this thing is only drawing a half an amp, so something's not quite right. All right, the output is hooked up. Signal trace. Let's signal trace. Okay, yep, got something there. And we should have it here. No. Here. Yep. Okay, the other channel should get us something there. Yep. Now are we passing signal? That's going to be the big thing. It actually doesn't seem like this first tube is working because it's not amplifying. So I wonder if we just simply have a bad preamp tube. Let me grab a preamp tube. Okay, I don't know if you could see what I was doing there. So here's a, this is a probe that I use. So basically this is just hooked up to a speaker, or excuse me, an instrument cable. So I've got the tip going to this probe that I just made up, and there's a capacitor in here in case I hit anything that's high voltage. This capacitor will block anything that high voltage entering here that I touch will be blocked by this capacitor that's here. So anything getting to this wire will only be the lower voltage AC signal that will go to the amplifier that's up here on the bench. This other one is just for ground. It's going to the chassis right here from the sleeve. So this is how I just do a simple signal trace without using the scope. I could plug it up to the scope and look at it on the scope too, but for me it's easier just to hook this up real quick and see it here. But I'm going to put a different tube in because what's happening is when I look at this first, so we got signal coming in. This on the input. See if I touch my input here. I know I've got signal coming in. It makes its way over here to the tube here. So that's where the signal gets put into the tube, and then what comes out of the tube should come out here on pin 1. Well, it was actually lower in volume with that other tube. It was barely even there, so maybe that's the problem. So we got a new tube plugged in there now. I would have expected something to start coming through on the output, and I still don't see anything there. Wow, still nothing. Got the signal that comes in, that's the grid. And then this is the plate. This is the plate signal, and it's almost non-existent. So I need to figure out what on this first stage is causing that to happen. Okay, so I poked around here for a minute and I figured out that there was no voltage on anything. There's no plate voltage, there was no anything. So I poked around and figured out that there was a blown high tension fuse. High tension fuse was blown. So we're going to replace that with a new 1 amp high tension fuse. We'll see if that resolves the issue. I wonder if that would have been caused by that intermittent connection. Let's fire it up again slowly and see if we get anything this time. Okay, let's see what we got now. Now we've got some voltages. There we go. Now we're starting to actually get some we're getting signal on the output too. So that was definitely the issue. Okay. There we go. Yeah, we can see. Okay, presence is working, bass is working, middle's working, treble, yep, everything's working now. We got sound. Okay. There's our standby, off standby. Alright, channel 2 work. Yep. And master volume works. We're at only 50 volts on the 58 volts on the input, so let's go ahead and dial it on up. Well, that's looking pretty damn good if I do say so myself. We're only, again at only 77 volts in, so let's keep dialing up a little bit. See where we get to on the power draw and everything here. Yeah, this is all looking pretty good. It's all looking pretty good. I think we resolved the problem. It was just that we had a blown fuse and we had one leg of this master volume came loose. That's probably the easiest fix that I have had in a little while. Nothing to do now except maybe play through it a minute. See what she sounds like. All right, I just spoke to this customer about his Marshall amp, and he said that one of the symptoms that it was having before it just completely wouldn't pass any signal was it didn't have enough treble. He had to crank the treble kind of all the way up to really get the sound that he was after. So I suggested that, well, maybe this thing hasn't been fully modified into super lead specs, and maybe if we just fully modified it all the way to up to super lead specs, it would have the amount of treble that he's after. So let's bust out some schematics and look and see what can be done. All right, now it's time for your favorite part of these episodes, the schematic time. Don't glaze over here. We're going to look at a couple of things. This is the 1959 model, which is the super lead, and we're going to compare it to the model that we have. Okay, so this is the 1992, which is the model that we have here, the super bass. And if we look here, we could see some differences between this one and the super lead. This model on the first tube here, this is one tube, and here's one half of the tube, here's the other half of the tube, and you can see they share a cathode bias resistor and bypass capacitor here. So they've got a 320 microfarad bypass capacitor and a 820 ohm bias resistor. You can see that's not the case here. They split it out into different bias resistors and bypass capacitors. So you can see here on one channel that comes in, here's the pair of inputs for one of the channels comes in here, and the bias for this side of the tube has the 820 and something very similar. It has a 250 microfarad capacitor instead of what they had on the other one, which was what, a 320? Yeah, 320. Okay, so that's a little bit different. It's a little bit lower bypass capacitor, but on this side it's way lower. It's a 0.68 microfarad, and that's much more in line with the later models that came along, the JMP 2204s. So this one has a 0.68 microfarad bypass capacitor here and a 2.7K resistor to bias this first stage. And you'll notice on these models, instead of only one gain stage and then on to the rest of the amplifier, we have cascaded gain stages. So this one, if you plug into the high sensitivity on the 2204, it goes through this gain stage and then goes through the low sensitivity input and then on to a second gain stage. So this first tube is split out so that it cascades through two gain stages, giving you more distortion. This one, however, it only has the one gain stage before this second gain stage and then the cathode follower. So you have 1, 2, and then on. If you put a jumper wire between these two, you're paralleling these first stages right here on both channels. So you're sending signal through both channels and paralleling that, and both of those are going through to this stage here. So different in that respect from the 2204s, but also different from the super leads, in that we've got broken out cathode bias resistors and capacitors here. And again, this configuration with the 2.7K and the 0.68 microfarad capacitor, this is where they the 1959 model, the super lead model, is where they developed this configuration for that first stage right there that we see in the later 2203s and 2204s, where we get that 0.68 and the 2.7 bias. If we put these side by side where you can see both here, that might actually be a little easier. The main difference is just that, is in the way that these are biased. If we look at some of the other differences, okay, so on this channel, this would be, okay, so this would be the more focused guitar channel that you would want to plug into. That would be these two inputs right here. So this is kind of more the for this time period, this would have been the more distorted, crunchy channel with a more Marshall-y, what we came to really define as the Marshall sound in the 80s. This would be kind of the more 80s sound. This would be the more 60s sound down here, plugging into these two. So if we get to the more 80s sound, if we plugged into this channel, you would see this side is biased with the 2.7K and this 0.68 bypass capacitor, and then through a 0.0022 capacitor right there. In the super bass, we have a 0.022. So they really are trying to filter out a lot of the bass, so it gives you more of a lead tone, hence the name super lead, and hence the name on this one, super bass. The owner of this one, he has complained about this being a little too bassy, like he has to crank the treble all the way up to really get to the sounds that he wants. So we're gonna check and see what all has been changed, and if it's what we expect to see and what we want to see for something that has been changed into super lead specs. So we need to look at all of these components right here. So these are different. We have to check this component coupling cap right here to make sure it's up to super lead specs. Also, this 0.005 capacitor right here, that's a little bright cap. I don't think this is in the amplifier because I don't see it on the pot. So I think they neglected to add this when they did the updates. Also, another thing that's missing is this 0.68 microfarad bypass capacitor on this stage here. So we need to add this. Also, you see here that 1K is in brackets. I think some of these were shipped with a 1K resistor and some were shipped with an 820. I think the 1K is probably going to be more gain. We'll check this and see what it is. We may, if it ends up being an 820 or 1K, we might leave it. But we might actually experiment with it too. But this is one that you could experiment with for sure. If you wanted more gain out of one of these 1959 Marshalls, or even if you had a super lead, if you wanted to try to pump a little bit more out of it, you could experiment with this stage right here. You could, I mean, of course, you could also split this out and cascade these stages and make it into like a 2203, and it would be a roaring beast at that point. But you would have to do some other things that they did in order to tame things down. I think the best approach is probably just to super lead this thing out and make sure that it is up to super lead specs. So first things first, let's look at these four components, which are the main difference. All right, so if we look here, this is the first tube. This is the one that's in that schematic, and then these are the bypass capacitors that are coming off of that tube. This is the 0.68, so it is indeed, this has indeed been made into super lead specs part of the way. I don't know if it's been fully made into super lead specs yet. We have a bias resistor over here. That one is a silver red. That would be an 820. We've got an 820 with the capacitor being 220 microfarad. So instead of 250, we've got a 220, which is fine. Basically close enough. Over here, we have a resistor that's been added. It's really hard for me to look and see what that is, though. That does not look like a 27, but is it? Yeah, it might be. Let me measure it instead, because I can't see what those... it's hard to tell what that color is, that second color. I think it's a 2.7, but I'm not sure. It looks like it might be a 2K. No, it's a 2.7. Okay. Okay, so that is a 2.7. So this part at least has been super leaded. Now we need to find this capacitor right here, 0.0022, and that'll be coming off of one of the plates. So we need to trace the plates. So this is pin number 1. That'll be one of the plates, and it's going to here. And if we look at the trace, we can actually see the trace under the board, which is kind of convenient. So that comes to this capacitor here. That one is the original capacitor, 22 nanofarad. So we're looking for 2.2 nanofarad. That would be this guy. Here's the blue wire for the other one. And that's no guarantee that yours will be like this, that you can just trace the blue wires. But if you go to pin 1, 2, 3, 4, 5, pin 6, that's going to be your other plate for the other side of that tube. That comes to here. This has been changed, but I want to know, and it says 0.022 on the board, but of course this, again, this is the base unit, not the super lead unit. Let me look at what that is. It's really impossible to see. It's the wrong damn way. Of course, somebody has to install it where it's the wrong direction. You can't read the value. I mean, that's just something simple, man. You know, okay, that is a 0.0022, so I had to roll it almost all the way off of the board to see the value. I guess I could have tested it, but man. All right, that is a 0.002. So that's been changed. This stuff has been changed, so we're good so far. We need to look for this bright cap. I think this bright cap might have been forgotten about. Yeah, that's supposed to go from one of the legs to the wiper, not the one that's going to ground. Leg to wiper of one of these pots, and I don't see anything. So we're going to add that bright cap, and again, that's going to be a 0.005 cap. Okay, bright cap installed. Now we need to get a 0.68 microfarad bypass capacitor, and it has to go basically around this 820 ohm resistor on this stage. Second tube is here, pin 3. This will be our cathode. So it is going to the board up to here. And indeed we do have an 820 right there, but we have to go around it with a capacitor. Can you see that 820 right there? What we really need to do is pull that 820, and we need to make up a stack of components. So we're going to have to lift the board again and pull that resistor right there and replace it. And while we're doing it, I think I'm going to change it from an 820 probably up to a 1K. That's going to give the amp more oomph. I know he'll appreciate it. I mean, everybody who has a Marshall, that's what they want them to do. They want them to scream. So if you want your amp to rock, there's not much sense pussyfooting around about it. You know what I mean? Just go ahead and get it done. These boards are so tough it's so tough to reach underneath them as it is, and they've got this stupid standoff up here. So jacked up, for one thing. This standoff screw over here is so tall, it's hard to get the board up off of it, and then you really don't have enough leads on some of these to lift the board to really get under there and desolder things. These are not that easy to work on. They're not like modern double-sided boards where you could just hit them from the top and get a component off. You really don't like to modify these too much if you can help it, because you keep having to pull the board up every time you want to change anything, and it's a real pain in the butt. We'll grab onto it here and see if we can't get a good purchase, and then try to keep from burning these wires. We'll get the wires out of the way. Okay, there's one side of it. Now this one on the far side, this is the real problem right here. Getting this one all the way back in there. Let me get something to prop this up. Yeah, there we go. Perfect. All right, we'll grab that. All right, need a new resistor and a new capacitor. So, and I keep these 0.68s on hand for this reason, because you do so many of these that this is one definitely that you stock for this purpose. And this is a pretty large capacitor, so we're going to have to do something to kind of get it. Well, first what you have to do is you kind of have to take these and bend the legs in like so. I'll show you. And when you're bending legs like this, you want to be careful not to break the seal on the capacitor around the legs if you can help it, because that's going to prevent moisture and everything from getting in over time. So what you want to do is you want to treat these legs with some respect and care, and just sort of bend them carefully, taking the pressure off the actual joint up here where it goes into the capacitor. So we bend these inward like so. That's the first thing. So they're going to have to come away inward. And then there we go. I think that's probably just about right. Yeah, that's perfect. All right, that's perfect. Now we're going to take our resistor and go between these 2 points. And we'll just shape our leads into a couple little circles at the ends of the resistor there, like so. And then we can just slide this capacitor right down onto it like that. And we'll solder that on there and then clip the excess. Okay, easy peasy. I'll snip the excess here and here, and then we will snip some of the excess from these leads also down here, because we only want it sticking down in there a little bit, and we want this right down onto the board if we can get it there. So we only want maybe about this much lead going through the board, something like that maybe. Like that right there. So that's how you're gonna want to do this. If you're doing your own, you want to do something like that to make it kind of clean, and this should just fit right down on there. All right, we'll get both legs in the hole like that and just hold it there while we solder from the other side, because we're gonna have to loosen that solder to get it to poke through, because I didn't suck the solder, so there's still some there. Let me see, let's try. All right, there's one side. Is the other side gonna go or not? There, ooh. Man, yeah, see, these traces are so fragile. They're so fragile. You gotta really be careful with these traces, man. They're so fragile. I need to make sure I didn't tear up that trace. I think I got it, but I don't know for sure. And the only reason I say that is because the trace did tear away from the board just a smidge, so I want to make sure that it's connected. It's really hard to do this where it doesn't tear away any at all on these boards. Anybody who's worked on these knows exactly what I'm talking about. These things have a tendency for the trace to tear away from the board, and that's what happened here. That's why this happened. Was that trace tore away from the board and caused the issue that we saw before. But yeah, that's there and it's good. Let me make sure we're connected over here too. Might as well. Okay, we're good there. And let me make sure we've got the correct resistance through that resistor, and we do. Let's see, there is one more difference. I forgot about that. We do have a tone stack difference. We have a 500 picofarad on the super lead right here on the treble cap, and we have only a 250 pico on this treble cap. Okay, yeah, that's still the original 250 pico. We're gonna have to take that out and replace that with a 500 picofarad. Yeah, same operation as last time. We got to kind of be on and off of here sort of quickly because we don't want to screw up these traces any more than we have to. There we go. Alright, now let's check and make sure we got that soldered in correctly, because it's really hard to see and it's hard to tell otherwise. Yes, there. And yes, there. This is interesting actually, because if we look at this schematic, this is the super base. It has the 250 picofarad just like we pulled out of there. But then it has a 56K resistor here. That resistor in the super lead model, it's really hard to see, I know, but it is supposed to be a 33K with that 500 picofarad. We put the 500 picofarad in and changed that. This resistor though is already a 33K in the example that we have. So for whatever reason, that resistor is already super leaded. It looks to me like it was original from the factory also. I think that's original from the factory, because look at the patina on that leg. I don't think there's any way that's not an original resistor. So it was already super leaded. So I'm sure they were still playing with values, and some of these are going to have different values. You might want to check that and see if maybe even A/B it and test it out, play test it and see if that's something you want to change. But at this point we've got everything super leaded, so we're going to button this all back down, check the bias, and then give it a listen. Alright guys, we're in the process of biasing this thing, and I want to show you something. We're really low on the bias. We're only dissipating about 9 watts per tube right now, according to these numbers at idle. Plate dissipation on EL34s is about 25 watts, and we're nowhere even close to that. We're nowhere even close to 70%. You know, 70% of 25 watts, 17.5 watts would be 70%, but we're not even anywhere near that. So I want to flip this over. I want to get this up on some stands, and we'll start fiddling with the bias a little bit. Okay, let's play with the bias here just a bit. I want to bias this down somewhere around 50%. I think is where I want to try to put this, just because I can't, up here on the bench, I can't really play test it while I have no cabinet here in the room with me, so I'm going to dial this. Let's see, till we get to about 50% of plate dissipation, maybe about 27. Let's try right there. But around 12 watts is kind of where I want to land, somewhere around in there. So let's go 0.0278 times 461. That's 12.8, almost there. Let's go to about 25. So let's go 0.0248 times 465 watts or volts, 11.5. That is a little bit less than 50%, so let's dial it back up to about 26. I think it was too low as it was. I think it was just simply too low. But right there, I think we're going to be good. At least I hope so. And plus, we are at the point of we do have a little bit of crossover distortion when everything is cranked, but it's not much at all. I think that's where I want to leave this, right there. We're at a good compromise point. Tubes are so expensive today, I don't want him to burn up tubes prematurely, and it looks to me like we're about where we want to be. So here's the tail of the tape on this thing, and this is about what I would expect for a 100 watt Marshall. Okay, so we're looking at right there at 119 volts in, we're looking at 130 watts total. That's for the entire amp at idle. 1.25 amps of current draw at idle for the whole amp. There is our plate current, and here is our plate voltage. Let's power her off and put her up on a cabinet and give her a sound test. guys, that's going to do it for this 1974 Marshall Super Bass, converted into a Super Lead. I hope you've enjoyed this one. If you have, hit subscribe down below, hit the like button, all that good jazz. I really appreciate it. It helps the channel a lot. I want to thank everybody for sticking around to the end of the video, and for now, we will see y'all later.